First thing you want to do when you're balancing an equation is to make sure that you find one thing that is not the same on both sides of the equation. What I mean is that you've got more or less of a particular atom on one side of the equation than on the other. So right now, the first thing I'm going to zoom in on, I'm going to take a look and recognize that I've got 3 NAs on this side. I've only got 1 Na on this side. So the first step would be to try to balance. And again, it doesn't matter where you start. Find one thing that is out of balance. So I'm going to put a 3 here, and that's intended to balance off my NAs. So if I do that, I also end up with 3 OHs. Remember, the coefficient, the number I put in front, causes everything behind it to be multiplied by that particular value. So if I have 3 OHs on my product side, take a look on my reactant side, I only have 1. So I need to put a 3 here as well. Again, that multiplies everything behind it, including the K. Well, that's all right though, right? Because on my reactant side now, I've got 3 Ks. On my product side, I've got 3 Ks. Let's take a look and see if everything else is balanced. So I've got 3 NAs on my reactant side, 3 NAs on my product side. I've got 1 PO4, and I notice I'm not going to split that up because it stays together as a unit. It stays together as a PO4. I've got 1 PO4 on the product side. So that looks balanced. On the reactant side, I've got 3 Ks. On the product side, I've got 3 Ks. On the reactant side, I've got 3 OHs. On the product side, I've got 3 OHs. Now don't forget, whenever we have blanks in front of a particular species, that does not mean there's 0 of them. It means there's 1. So I want you to get in the habit of filling these in. All right? So that means I have 1 of each of those ionic compounds. All right, let's do a couple others. Let's do the next one, MgF2. So once again, you'll start to pick up quickly on which species, which atoms aren't balanced. So I've got 2 Fs on the reactant side. I need to have 2 on the product side as well. That means I not only have 2 Fs on the product side, I also have 2 Lis on the product side. And that's okay because I've got 2 Lis on the reactant side also. If I take a look at my CO3s, I've got 1 CO3 here. Oh, I've got 1 CO3 here as well. So that looks like it's balanced. Let's just double check and make sure everything else is. Let's just focus on the reactant side. 1 Mg here, 1 Mg here. 2 Fs here. Yeah, I've got 2 Fs over here. 2 Lis here. I do have 2 Lis on the product side. 1 carbonate, 1 carbonate. So once again, I'd be putting in 1s in front of these in order to make sure that I know that there are coefficients there. There's 1 of each of those ionic compounds. Phosphorus is another one of those unique things on the periodic table. When it's by itself, it never ever exists as a single atom. There's always 4 of them that kind of come together. Sulfur is the other one you have to remember. Remember sulfur, just put it off to the side here so it doesn't confuse us. Sulfur is S8, and then you have all your diatomics like oxygen, right? They are with a little 2. So let's take a look and see. Right now, I've got 2 oxygens on my reactant side, 3 on the product side. This is where you have to think of the lowest common multiple. Lowest common multiple between a 2 and a 3 is 6. So I'm trying to get 6 oxygens on both sides. So I need to put a 2 in front here, because 2 times 3 will give me 6. Then I need to put a 3 here, because 3 times 2 will give me 6. Now my oxygens are balanced. 6 on the reactant side, 6 on the product side. Let's take a look at the phosphoruses. 2 times 2 is 4 phosphoruses, and I do have 4 phosphoruses on the reactant side. All right, so there you go. Those are the first 3. I will post this this worksheet, and I'll post the answers as well. All right, so if you need to, you can look back at this video to help you along with the first couple, and then you can blast through the rest for practice, and you can double check the answers.